Khan. This is MOHSIN Khan. You watching Risky Networking. Guys, I'm sorry. I know I'm uploading this video a little late, but I was having so many reasons for that. But I'm not gonna explain those reasons right now. I'll be explaining those in the end of this video. And I just wanna quickly jump, whatever we will be covering in this video. So I will be covering few questions which I asked on my page in this video. And before doing that, if you remember in my last video, I asked you two questions, and those questions were about routing protocols. One question was related to RIP version 1 and another question was related to OSPF. Okay, so I asked you, first question was on which multicast IP address RIP sends its routing update, and this was not the question. On what address actually? Okay, on what address RIP version 1 sends its routing update, and the other question was about OSPF multicast IP addresses, that when OSPF will gonna use .5 and when it will gonna use .6. So that these two things, first of all, I'll be explaining you, and after that, after that we will be jumping on the Facebook page and we'll try to cover some more questions, so which are already on the page. So let me explain you first of all the question number 1, RIP version 1. So guys, RIP version 1 always sends its routing updates on broadcast IP address, and the broadcast IP address means it is 255.255.255.255. This is the broadcast IP address. So whenever a RIP version 1 is sending its routing update, it always send, or you will always see the destination IP address as 255.255.255.255. Okay, so this is one scenario. It was pretty straightforward question, and I have seen so many candidates has given the correct answer. I'll show you who has given the correct answer, but before jumping on that, I also want to explain you the second question, and the second question was about OSPF. Let me show you that. Okay, cool. So I ask you guys that, see, OSPF uses two multicast IP addresses. I'll take little time in explaining this because this question, this concept is very, very, very important, and so many people are having doubts, but I have seen people has answered it correctly, so it was very appreciative. I'll be showing you the names of the people who answered it correctly, but still it is my responsibility to explain it in a proper way. So just guys, see, let me tell you the IP addresses which OSPF uses. So those are like 224.0.0.5 and another one is 224.0.0.6. So these two multicast IP addresses OSPF uses. So let me show you. This is a switch, for example. Now few routers are connected to this. Come on, I'm sorry for this. Some unnecessary pop-up came, guys, so I just blurred the screen. I don't want it, I want you to get distracted, and it was asking some software update, so leave it. Okay, so guys, this is a switch. Few routers are connected. It is R1, let's say it is R2, it is R3, it is R4, it is R5. I'm not interested how OSPF will going to elect DR, designated router, backup designated router, and designated router others. I'm not at all interested in that. Just assume that, guys, that R1 has become the DR, R2 has become the BDR, actually BDR, and the rest of the routers, they will become what? They will become DR others, DRO, right? Now my question was, when OSPF will going to send updates packets on .5 and when it will gonna send its updates on .6. So always keep one thing in your mind. Whenever a DR or BDR, and listen to me carefully what I am saying, right? Whether I'm talking about sending or I'm talking about receiving, because most of the time I have seen when I was interviewing people, I have seen people are having doubt that they are getting confused in receiving and sending. So these two things are very important, so just listen to me carefully so that you will not going to do the similar kind of mistakes, okay, whenever you will face an interview. So guys, for example, what I'm saying, I'm talking about sending. Okay, so whenever a DR and a BDR send its routing update, or any, like for a triggered update, let's say for example there is a network and this network is going down. So what R1 will do, R1 is a DR or whatever it is, it will gonna trigger the routing update. So when it will trigger the routing update, guys, it will, or whether it is a BDR, whether DR, okay, both, so it will always send its routing update on 224.0.0.6 I'm sorry, what I'm sorry, .5, okay, don't get confused. So DR and BDR always send their routing update on 224.0.0.5 whenever, so yeah, exactly. And always remember, now I'm talking about receiving part, or let's talk about send part first and then we will cover the receive part also, okay. Now another example. So okay, there are three type of routers, one DR, another one is BDR. So I have already explained you what these two router will do when they will need to send any update, okay. Now what a DRO will do, okay, what a DRO will do, for example, this is a DRO, there is a network, it will went down. So on which address DRO will trigger the update, okay. So DRO will always send, I'm talking about sending, DRO will always send its routing update, I'm talking about routing update, on 224.0.0.6. Understood? To be honest, this is the only use of .6 multicast IP address, that whenever a DRO need to send any kind of routing update, it will gonna send on .6. Okay, now this was about sending. So any DR BDR will send on .5 and DRO will gonna send on .6. Now I will talk about receiving. For example, let us assume, guys, there is a packet, okay, one packet is coming to BDR, okay, one packet is coming on BDR, and that means BDR is receiving it, okay. So BDR is receiving it. So listen to me carefully. When it will come to receiving, all the routers, every single router, whether it is a DR, whether it is a BDR, whether it is a DRO, all the routers can receive okay receive update packets. I'm talking about routing update packets, okay. All the routing update, actually all the routing update packets, they can receive, which are coming from 224.0.0.5. I'm sorry, not from, coming to, because this will gonna be destination, okay. So all the, or let's understand this in this way, that all the update packets which are having a destination IP address as 224.0.0.5, every single router, whether it is a DR, BDR or DRO, that router will gonna receive that packet. Understood? Now this multicast address, so when it will come to sending, DR and BDR can only send the updates on .5. When it will come to receiving, every single router can receive all the updates which are having destination IP address as 224.0.0.5. Now let's talk about the receiving of .6. So for example, if you are receiving a packet on .6, guys, only DR and BDR can receive on 224.0.0.6. Understood? That means a DRO can never accept a update packet with a destination IP address as 224.0.0.6. You listen, understood? Please understand me clearly, right? Or what I say carefully, right? What I'm saying, focus on that. So I'm saying whenever a DR and BDR is sending on dot 5, or I'm saying I mean DR and BDR always send on dot 5 the update packets, and DRO always send on dot 6. So just as okay, and the receiving part, DR, BDR and DRO, everyone can receive means accept update packet. I'm continuously saying update packet means routing update packet, which is having a destination multicast address as dot 5, but the routing update packet which is having a destination multicast address as dot 6, only these two routers DR and BDR can accept that. Okay, so that means what? That means, assume guys, in future this is a DR other router, it is receiving, or it is, one packet is coming towards it, and that packet is having a destination multicast IP of dot 6. So what DRO will do? Will it accept it? Absolutely not. DRO can never accept update packet which is coming on dot 6. And guys, you tell me, who will gonna send this kind of update packet? Only a DRO can send a update packet with a destination IP of dot 6. Okay, that means what? A update packet coming from one DRO, the same update packet cannot accept by another DRO, okay, or cannot be accepted. So one DRO will never accept a routing update coming from another DRO. A DRO will always listen to its DR and BDR. This is the concept, and this is the reason why we are having two addresses. This concept help us to reduce the processing overhead in the entire this broadcast domain. Why? How? That is like something which I'll not gonna discuss at this point of time, but I just wanted to show you that when the Dion, when like OSPF will gonna use dot 5 and when it will gonna use dot 6. Now my another question, for example, this was I was talking about update packets, okay, but guys, tell me one thing. Apart from update packet, there is one packet which OSPF sends periodically, and that packet is the hello packet. Why OSPF sends hello packet periodically? Because in order to maintain the neighbor relationship, right? And that every single router will gonna send. Do you know on which multicast IP address OSPF sends its hello packet? Every single router, whether you are a DR, a BDR or a DR other, you will always gonna send your hello packet on 224.0.0.5 every single time. So that means what? That means dot 5 with any packet of OSPF. Just understand it like in a way, every packet of OSPF with a destination IP of dot 5, every router can accept that, okay? But a packet with a destination IP address of dot 6, 224.0.0.6, only a DR and a BDR can accept. A DRO can never accept such packet. This is the way we have designed OSPF, or who has designed who, so this is the way OSPF is designed. Okay, so this was the concept, guys, and so many people has sorry, so many people has given the correct answer. Let me show you. So Cisco networking classes, any router will send update on DR. If a DR router will send the update to any router, then DR router will use. Okay, It means all router will listen 224.0. Absolutely correct. Exactly, he is absolutely correct. This is telling the same way, right? The DR will send its update on .5, so every single router will gonna listen. Listen means it will accept. So that is what I said. .5 everyone can accept. If any router will send update to DR router, then that router will use .6 to send. It means DR router is listen the. Okay, this statement is correct, but it is not that clear. The second statement is very much clear. I appreciate that, but this statement is is not completely not having the complete explanation. So it's cool, right? I explained you everything. And yeah, so RIP version 1 use is absolutely correct. 255.255.255.255 exactly. So that's it guys, right? Yeah, exactly, it is correct. OSPF uses to send information to all OSPF speaking, while uses .6 to send information to designated. Yes, absolutely correct. Yeah, it is also correct. Good, I appreciate. Who is this? Written. Yeah, he is. Every time he is giving the correct answer. I appreciate Written, your knowledge and your learning spirit. Keep it up, okay? And okay, great content, my man. Thank you. I didn't know why DNS. Okay, so he wasn't knowing. See, guys, so this is what actually, yeah, people knows that DNS is defined under TCP and UDP both, but very few people knows the actual concept that why it is defined. We know, when oh, guys, just advice, right? Whenever you are learning something, think why it is defined like this. When you will start thinking the answer of why, you will automatically start getting the answer of these kind of tricky things, okay? Or you can say people very rarely know these things, and I glad to know that people are learning, so it's great. Mukesh, again, Mukesh is always giving the correct answer. Let me see. When a router send DR to BDR, it was used. Okay, yeah, it's correct, but okay, it's cool. Then DR will send updates out of order. Okay, process. Thanks. Oh yeah, I remember. I especially picked that topic for Mukesh. So thank you, Mukesh. It's cool. I appreciate that. Okay, you're most welcome. That's it, guys. So it's cool, and to 425 subscribers. It's cool, right? Just keep hitting that subscribe button, guys. Right? We wanna reach 1,000, and then we will be starting live streaming. Okay, so this was the question which I explained to you in the last class. Let's start with the another question. Okay, this is about multicast MAC addresses. Cool. So the question is, what multicast MAC address CDP uses to send its periodic update? Guys, the correct answer is option C, 01:00:0C that's CC::CC::CC. So that is the multicast MAC used by Cisco Discovery Protocol. You can sniff it, you can see it. Maybe sometime when I will cover CDP protocol, I'll gonna sniff it. I'll show you, right? That yeah. So don't worry, it's cool. Ramveer Chaudhary has given the correct answer. Well done, Ramveer. Yeah, he is correct. C is the correct answer. Absolutely correct. Very nice. Okay. What multicast MAC address VTP uses to send its periodic update? So VTP, VLAN synchronization protocol, right? It uses, okay, to synchronize the VLANs. So again, guys, VTP also uses the same multicast MAC address as CDP. So this will also gonna be the CC::CC::CC. Option C is the correct. And 5 comments. Sudesh, C. Kumar, Suman, nice. Ramveer again. I think VTP and CDP uses same multicast. Okay, I am giving the hint. Yes, okay, that's cool. So fine, yeah. So again, yeah, VTP and CDP use the same multicast MAC address in order to send. And very well done, everyone who has given the correct answer. So there is Kumar, Suman, Ramveer. Excellent. Okay, here is something interesting came. Okay, so what multicast MAC address Eigrp uses to send its routing update? I don't know how many of you have heard about this, but let me tell you one thing. Guys, it's very simple. Okay, just listen to me carefully. For example, if I am sending a unicast packet, a unicast request, so my destination IP address will be a unicast IP. Let me show you. For example, if I am sending a unicast, this is a PC, is connected to this PC 1.1, 1.2, let's say. Okay, now for example, if I want to send a unicast request, the destination IP will be a unicast IP, right? I am sending to a specific machine, so my destination IP in that case would gonna be 1.2. In the same way, the destination MAC address will also gonna be a unicast MAC address. The MAC address of this specific PC, assuming it is 00B. So the destination MAC will gonna be 00B in that unicast packet. For example, you are sending a broadcast packet. Okay, so what would gonna be the destination IP for the broadcast packet, guys? It will gonna be 255.255.255.255. In the same way, for the same packet, guys, just because the IP address of the destination is a broadcast IP address, the same rule will apply on the MAC address as well, guys. So if it is a broadcast packet, guys, the MAC address will gonna be a broadcast MAC address, which is, everyone knows, FFFF12Fs. So this is the the broadcast MAC address. Okay, so guys, just like a unicast packet is having unicast IP and unicast MAC, a broadcast packet is having broadcast IP and broadcast MAC. In the same way, if you are sending a packet, let's say a hello packet of Eigrp, you will always gonna send the hello packet on destination IP address will gonna be 224.0.0.10. The destination IP address of Eigrp is 224.0.0.10. So guys, for example, you are on network layer, right? So network layer source IP, let's say it is the source IP address. Okay, and destination IP, so this is the source IP and this will gonna be destination, and it is 224.0.0.10, right? And here I'm having let's say a data, whatever it is, Eigrp, what I say, header will gonna be there. Okay, so now on data link layer, you will gonna add the Ethernet header, and the Ethernet header will have what? It will have the source MAC and the destination MAC. Obviously, source MAC will be the MAC address of the interface of the router. Okay, so router, router's MAC address, for example, this is the router, let's say R1, this is 0/0. So whatever the MAC address of this 0/0 will be, the router will add its interface MAC address in the source MAC address field. What will be the destination MAC, guys? So as I told you that as the IP address, the destination IP address is a multicast IP address, guys. Just because of that, the destination MAC should be a multicast MAC as well. Okay, so both the addresses will be of similar type, I can say. If a IP address is a unicast, the destination IP, then destination MAC will be unicast. If the destination IP is multicast, in the same way, the destination MAC will also be the multicast MAC. But what will be the multicast MAC, right? For example, unicast MAC, how it is calculating we don't need to calculate a unicast MAC. It is already hard coded on that interface. The MAC comes with that interface. It will remains the same. Okay, for in case of unicast. Now, in case of broadcast, we know that there is one broadcast MAC address, and that is 255.255. It will always remains the same. But what about, guys, multicast? I haven't seen a specific multicast MAC is defined, right? So guys, actually we need to calculate the multicast MAC address with the help of its respective multicast IP address. Exactly, right? So for example, if this is the multicast IP address, there is a dedicated multicast MAC address for this specific multicast IP address, right? So as you know that we are having two part of the MAC address, right? Like we can divide a single MAC address in two different fields. One, colon, colon, colon. So these six hex, actually these will be six hexadecimal digits, means first 24 bits, first 24 bits, total 48 bits, right? So just divide that in the half. So one first half will consist of 24 bits. So these 24 bits called organization unique identifier, OUI, right? And then another 24 bits will be there, and these are called vendor assigned or something like that, right? But this is, this vendor assigned will apply when we are talking about the unicast MAC, which is hard coded on the physical interface. So in this case, these 24 bits, the second half, okay. But when it will come to the multicast concept, no vendor will gonna assign any multicast MAC, right? Because we will going to drive the multicast MAC, guys, okay, with the help of this multicast IP address. Understood? So there will not gonna be any OUI, any organizational unique identifier, because a multicast doesn't belong to any particular organization. It belongs to a particular protocol. So in this case, in this multicast MAC address, right, these 24 bits, these are reserved. These bits are reserved and these bits are derived. Okay, we will be driving these bits with the help of this the multicast IP address, right? So these like 6 hexadecimal digits. Let me show you guys. Have a look at this. Just have a look at this option, right? These all the 4 options, guys. Just have a look on the first 6 hexadecimal digits. All the first 6 hexadecimal digits are same, 01 colon 00 colon 5e. So actually, if a MAC address, if you are looking at a MAC address and if you are seeing first 6 hexadecimal digits as 01 colon 00 colon 5e, guys, that means that address is a multicast MAC address. Actually, these 6, the combination of these 6 hexadecimal digits are reserved, or is this combination is reserved for multicast MAC, right? So 01005E. So these bits will always gonna be 01005E. Understood? Now guys, see, we are having first 24 bits. Now we need further 24 bits in order to complete this MAC address. Now from where we can take these 24 bits? Take care of one thing. We need 24 bits. Okay, now guys, I'm saying that these remaining 6 bits we will be driving from the it's specific or respective, it's respective multicast IP address. So this is the multicast IP address, and we know every IP, the size of every IP is 32 bit, but we only need 24 bits. Okay, so which bits we will be taking in order to drive these 24? Okay, so guys, we will not gonna consider the first octet. We will just take second, third and fourth octet in order to calculate the multicast MAC address of any multicast IP address, right? So now let me tell you one thing. This octet, okay, this octet, okay, so see 8, so one octet is having 8 bits. So 8 bits plus 8 plus 8, in total how many bits you will get? You will get 24 bits. And yeah, we need 24 bits only. So let's focus on this octet, which is 0. The decimal value of that octet is 0. let's say the decimal is 0 of second octet, then what will gonna be its binary? The binary will become, see, 8 bits we are having, so binary will become what? All 0, right? So 1 2 3 4, so 8 bits 0, you will get a 0 in the decimal. Okay, now guys, do you know what is the size of one hex? Okay, wait a minute. This is a decimal value. This is a binary value. And we all know our MAC address is present in hexadecimal value. Okay. So now what I'll do? Okay, do you know what is the size of one hexadecimal digit? Guys, one hexadecimal digit consists of 4 bits. Understood? Now you are having a binary. In binary you are having 8 binary bits in total. Now what I'm saying drive a MAC address from this IP address, means from this binary you need to drive the hexadecimal digits of the MAC address. Okay, now what is the size of one hexadecimal digit? 4 bits. How many bits we are having right now? We are having 8 bits. That means what? That means you just need to divide these 8 bits into 4 bits. So you will get 2 pairs of 4 bits, right? In each pair you need to maintain 4 bits because we need to convert this binary into hexadecimal. Why? Because we need to convert this IP into MAC address. So what hexadecimal you will get? Hexadecimal. So guys, all 0 means you will get a 0 in hexadecimal because 0 is present in the hexadecimal. What is the range of hexadecimal digits, guys? 0 to 9, A to F. Correct? So 0 means 0 and here also 0. So in that means what? You got 2 hexadecimal digits and both are 0 just because the value of second octet was 0 and whatever the value we were having in that, we got these 2 hexadecimal digits when we divided 8 binary bits into 4 right, binary bits, and just we converted that binary into hexadecimal, so we got 0 0. So guys, you got your 2 hexadecimal digit which are 0 0. Now another 2, here we will have 2 hexadecimal digits. We will be calculating those 2 from the third octet, again 0. The third octet is also having 0. So the same thing will happen. You will convert that decimal 0 into binary, you will get this. Again you will divide into 4 bits, right? So you will get 2 pairs and then you will convert into hexadecimal, you will get 0 0. So again you will have 0 0. These are hexadecimal digits. These are decimals. These are binaries. So we are converting decimal into binary and then further we are converting binary into hexadecimal, and whatever the value we are getting in hexadecimal, I am considering that as the digits of my MAC address. Now in the fourth octet I am having 10. What now, guys? See, decimal value is 10. It is 10. Now convert this 10 into binary. It's very easy, right? In IP address I'll gonna show you how to convert any decimal into binary into decimal, just like that. Okay, you don't need to use your pen and paper, and you can convert them in your mind, right? It's like very easy. You just need a basic kind of practice and you will be able to do that. Okay, so I'm just directly converting it 0 0 0 0, then 1 0 1 0. So guys, this is the binary of 10. Because we are having 8 bits, so I have converted this binary in the form of 8 bits. So if you are converting this, so you will get this. Now what you need to do, you just need to okay, you need to just divide these bits into 2 pairs, like first 4 bits and the remaining 4 bits, right? Now just convert these into hexadecimal. What will you get, guys? 0 0 0 0. What will you get? You will get 0. Now for this, if you will add these, see, okay, so these 4 bits, if you will convert them into hexadecimal, let's say, what will you get? Or just think what decimal value you will get. So here it will become 0. It will be, see, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So the bits which are having a value of 1, just add their respective 2 to the power values. Okay, so it will become 2, this will become 2 to the power 3 means 8, it will become 10. But if it was when it was decimal, we were writing it as 10, but in hexadecimal we are representing 10 as a, right? So if it is coming as 10, you will be writing it as a in hexadecimal. So that means the fourth the last two digits, the hexadecimal digits, will become what? 0A, 0 and A. So guys, this is the MAC address, actually the multicast MAC address of every Eigrp multicast packet. Because whenever a Eigrp send its multicast update, multicast hello, it will always gonna send on .10, 224.0.0.10, and whenever you will have this IP, you will always gonna get a multicast MAC as this, guys, right? So you can check it, you can sniff it. If you were knowing this already, it's very nice. But if you now only you got to know, okay, so we are also having multicast MAC address as well. So guys, you don't need to go to layer 3 in order to find out which whether this packet belongs to Eigrp or not. Just by looking at multicast MAC on the data link layer, your device will got to know, okay, this packet belongs to Eigrp. Okay, so whether I need to accept it or I need to drop it, a device can even take that decision on data link layer. You don't need to further decapsulate to network layer. Understand that? So okay, so I hope you learned this and this concept is clear to you. Now let's see. Okay, so I asked this, so 01005A, these will always remain the same, 00000A. So option A is the correct, and let's see who has given the correct answer. Option A, yeah, option A. Sudesh, Kumar, Suman, Vikash, both all of them are right. All of them are right. Very good, appreciate. Very nice, everyone. Another question, RIP. Okay guys, so multicast MAC address. So in order to answer this question, you should know we can use the another. Okay, fine. So okay, so what multicast IP RIP uses, guys? RIP uses 224.0.0.9. This is the multicast IP address of the RIP. Okay, now you need to calculate the multicast MAC address. So first 6 hexadecimal digits will remain the same every time. If it is a multicast MAC address, 01:00:5E. Now you need to calculate these two, and these two. And though for these 6 hexadecimal digits, you will be using the bits of second, third and fourth octet. And as I told you, in the second octet it is 0. So you will have 8 bits. Divide those 8 bits and all will be 0. Divide, you will get 40, 40. If you will convert those into hexadecimal, you will get 00. So I'm directly writing as 00. The third octet is again 0, so you will get 00. Now another octet is 9. So let's see. So if 9 is a decimal, what binary you will get, guys? You will get the binary as 0 0 0 0 1 0 0 1. Yeah, so this will gonna be the binary of 9. So just divide them into like pair of like 4 bits. So you will get 2 pairs. right? And if you will convert these 4 binary into the hexadecimal, you will get 0. And if you will convert this into hexadecimal, you will get what? This will gonna be 2 to the power 0, this will gonna be 2 to the power 3, 2 to the power 3 is 8, 2 to the power 0 is 1, add them, you will get 9. And guys, in whether it is decimal or hexadecimal, we write 9 as 9, okay? But don't consider it as decimal, it is hexadecimal value. So even in hexadecimal you will get 9. So this will gonna be the multicast MAC address of RIP version 2 update packet. What is the correct answer? D is the correct answer. 0 0, yeah, D is the correct answer, guys. Okay, few comments are there. Kumar Suman Sudesh, because everyone D, yeah, exactly. Well done, guys, well done. Multicast MAC addresses the OSPF uses to send its routing update. Let me show you. So first IP is 224.0.0.5. Another one is 224.0.0.6. We have already discussed about these two IPs in a very much detail. And so first bits will gonna be 0, 1, then 0, 0, then 5E, then so see 0 means 0 0. I am talking about these. And again 0 0 because third octet we are having all zeros, and here we are having 5. If you will convert it, guys, you will have first 0 and another 5, because because the what is the binary of 5. So if the binary of 5 will be yeah, this will gonna be the binary of 5. So just divide them into 2 pairs, like 4 bits in each pair. So this will be 0, and this will gonna be what? You will get 5, okay? And in decimal and hexadecimal we write 5 as 5. So it will be like that. And for 224.0.0.6 you will get 0 1 0 0 5E. Again 0 0 0 0. Now 6. What will be the binary of 6? 0 0 0 0 0 1 1 0. So just divide them, you will get 0. So 0, and here you will get 6. We will write 6 in decimal, in hexadecimal as well. Now guys, one question I'm asking you. For example, there is a multicast, like it is a random IP, okay? 224 dot, let's say 128.250.45. This is the IP 224.128.250.45. Now as you know, this is a multicast IP address. It is a multicast IP address. You have to tell me in the comment section what will gonna be the multicast. What will gonna be the multicast MAC address of this multicast IP address. So I'll be waiting for your response. Please comment below, guys. Just let me know you understood it clearly or not, because understanding the concept is the ultimate goal for all of us, right? And for me, actually, when I'll get the confirmation, yes, you can calculate or you can convert and you learned it, okay, then I'll be I'll also feel more satisfied. So it's cool. Let me see any further questions. Okay guys, so let's okay, stop the video at this point. Thank you so much, guys, if you're watching this video. I really appreciate that. Okay, and guys, if you really find this video informative, hit the like button, do the comment below. Okay, I already asked you one question in front of you, which is, so answer me. I'll be waiting for your response. Another thing, if you really find this video informative, comment below, let me know what are all the things you like about my video, what are all the things you want me to improve. I will definitely improve, guys. I'll definitely consider your whatever the comment you will do. I'm actually reading every single comment very carefully. And another thing, guys, share this video if you really find this video informative, if you really like what I'm doing. Subscribe my channel. Come on, guys, don't go without subscribing. Hit the subscribe button, guys. Click on the bell icon as well, so that you will receive the notification. And after getting 1,000 subscribers, I'll be starting the live streaming live streaming will gonna be fun. I'm always telling you, again I'm telling you guys, in the live streaming we will be covering so many practical stuff which we are dealing in a live scenario. Recently I was, I have done so many, a lot of things, and I faced so many challenges as well. So those kind of things which, are something which, we can interact on live, because those things are about practical scenarios. These topics right now I'm covering from the basics, so I cannot jump directly to the advanced things. So I will have two things. For example, one, these kind of recorded videos I can cover the topics which are very basic, because I have to go from the scratch. Okay, I cannot directly jump to the advanced topics, right? Because I have seen so many people are there who are watching my videos and they are from ccna. I don't want to scare them. Okay, so for experienced person, I'm not denying, obviously if someone is experienced, he don't want to need these things. But let me tell you one important thing. If you are thinking you are experienced, okay, I don't want to these cover those things, I'm telling you guys, people who are having 6 years of experience, I interviewed them, they don't even know the basic things. And if you don't know the basic things, when you are claiming that I'm having a 6 years, 7 years, 8 years of experience, and people are asking you the basic stuff and you are not able to answer it, guys, it will gonna put a very negative impact in front of the interviewer, right? He will definitely, it will definitely gonna put a question mark whether he will gonna select you or he will gonna reject you. So don't think like that. Okay, everything is important for every person. But okay, but apart from this thing, I know, as if you are working as an engineer, I'm talking little fast, I have to finish this. Okay, I don't want to extend these things more. So yeah, but yeah, if you are experienced, I know you will expect from me that I should cover some practical scenario or some scenario based questions, or some scenarios which we normally dealing in the real time, and how to deal with those things. So I will be covering in the live streaming. So live streaming will be for the people who are experienced. These recorded lectures, obviously in the recorded also, one day I will cover so many advanced topics, right? Even I will be covering BGP, MPLS, firewall, I will be touching VPNs, DMVPN, get VPN, all kind of VPN and all that. SD-WAN we will be covering very soon. I'll be covering that also, but that will take little time. Okay, I cannot jump directly on that. So live streaming will gonna be for the experienced person, or who know the basics, and they can directly jump, or they, who can feel comfortable with the implementation part and all that, so they can, the live streaming will be for them. And these kind of videos, just follow these things, guys. I'm starting from the basic, and very soon I'll be covering the advanced topic as well. So guys, keep supporting me like this. I really appreciate you are liking my video, you are doing comments. I'm getting very good response, very like a positive response from people, that people are liking my work, and that is the only motivation I'm having. I'm telling you guys, if you really liking what I'm doing, do the comment below, let me know, guys. It will take 1 minute of yours, but it will give me the how much motivation or inspiration it will give me. You have no idea, because this is the only thing I'm getting as a reward right now. Okay, this is the only reward for me, guys. You're hitting the like button, if you're hitting the subscribe button, and you are commenting and you are appreciating my work, my work, guys. This is the only reward I'm having, right? So that's it, guys. And also, guys, really share the videos if you really find that someone also can learn from this. So share it, guys, with your friends, with your colleagues who are also doing networking. That's it, guys. This is MOHSIN Khan. You're watching Risky Networking. Let's learn together. I got very excited. Take care. Bye, guys.